Next, we are going to demonstrate the functionality currently provided by the Similarity search component in SmartDataLake. We have seen before that Raw and Proteus support range and join queries in SQL based on exact match Boolean criteria. In contrast, our Similarity search software enables searching for the top K entities, mostly similar to multiple user-specified criteria. We have deployed a web service for this Similarity search component instantiated against about 6 million companies active in 2019 across Italy, and this data has been extracted from the Atoka dataset provided by our partner SmartDataLake. Similarity search accepts attribute data from heterogeneous, perhaps even remote data sources. So data can be either ingested from CSV files or queried in situ via JDBC connections to databases or requests to REST APIs like Elasticsearch. In particular, for this demo, we have extracted 3 representative attributes: the annual revenue, which is a numerical attribute, keywords, which is a set value textual attribute, and the locations of the companies, which is of course a spatial attribute. Let's see on the server side how this can be specified. Using a JSON configuration, this contains 2 main blocks. The first one concerns the data sources, which can be either CSV files or JDBC connections to a database like Proteus in this particular case, or REST API sources like Elasticsearch. The second block in this JSON configures the attributes that will be available for Similarity search. And here the administrator can define the name of the attribute as well as the type of the operation that we will support. Once the service is properly deployed and data sources have been configured, users can specify Similarity search queries involving one or more of these available properties. For example, a user can specify a top 30 Similarity search that involves companies that have a revenue of around 1 million euros, deal with tourism and accommodation, and are located in or around Florence. On the client side, we have developed a web interface that allows users to interact and specify top K Similarity search queries against the Atoka dataset in order to explore this information. Users can specify which attributes will take part in the Similarity search and define the query values for each attribute. They also have the ability to specify weights for each attribute. These weights control how much each attribute will influence the final results and the rankings. In this case, let's keep the default weights all equal to 1 and let's modify the alternative weights. Let's say that we specify a value of 90% for location. Let's keep the weight for keywords to 1, but let's say that revenue is less important in this case, so let's move it to 60%. We specify K equal to 30, so we want to find the top 30 companies that are most similar to these values. And in order to be able to run this query, users must also specify a valid API key in order to prevent third-party access to this sensitive proprietary data. So once the user hits search, individual KNN queries run in the background for each attribute, and their candidate results are aggregated and ranked. And indeed, after a while, the final ranked results are available and they are listed into lists, one for each combination of weights. The users can inspect the names of the companies matching the Similarity search criteria, the overall score per result, as well as the values and the scores per particular attribute involved in the Similarity search. If the user clicks on a company name, the respective web page in Atoka is available and users can inspect the full information about this company. We can also visually compare the two result sets in terms of their rankings. As you can see, the Spearman coefficient between the two ranked lists is 0.19, which means that there's no so much correlation. And as we can inspect, several companies have increased rankings with the default values, of the weights. Others have dropped in ranking with the alternative ones. And here you can see this chart which displays visually the changes in the rankings. And in fact, you can see that with the alternative rankings, you have 19 new companies in the results that did not exist with the default weights.